Hi friends, welcome to Edtechpedia. Today we will see about construction of alternator, that is synchronous generator, and working principle of alternator. First we will see about the working principle of DC generator. The generator in general, the generator is convert the mechanical energy into electrical energy. So the DC generator will be produces the mechanical energy is converted into DC electrical energy. Similarly, the alternators, that is synchronous generator, also the mechanical energy is converted into three-phase AC electrical output. So the working principle of alternator is similar to the DC generator, that is electromagnetic induction principle. Then the construction wise, the armature winding and field winding are different in alternators and DC generator. In DC generator, the armature windings are stator and field windings are rotor. But in an alternator, the armature winding is stator and field winding is rotor. This is the major difference in a DC generator and alternator. In DC generator, armature winding is rotor and field winding is stator. But in an alternator, armature winding is stator and field winding is rotor. And also the output frequency is directly proportional to the rotor speed. So to maintain the constant frequency, the rotor must always move at synchronous speed. Then we will see about the merits of stationary armature, because in an alternator the armature windings are stationary. So these are the advantages of armature winding. The first one is better installation, easy of current collection, increased armature tooth strength, more rigid construction, residue armature leakage reactants, lesser number of slip rings, lesser rotor weight and inertia, ventilation and dissipations are improved. These are the major advantages of stationary armature. Then we will see about construction of alternator. In a construction of alternator, the two major parts will be discussed. The first one is stator and next one is the rotor. The stationary part of the machine will be called as stator. The rotating part of the machine will be called as rotor. So in this, the stators are built with sheet steel lamination and also it's as inner periphery slots. Then the three-phase winding is placed on these slots and serves as the armature winding of the alternator. Then we will see about rotor. It carries the field winding which is supplied with DC through two slip rings by separate DC source. And also the rotor construction has two types. One is the salient pole or projecting type pole. Second one is the non-salient pole or smooth symmetrical type pole. First we will see about salient pole type. This is the simple construction of salient pole type. In this, the poles all are projecting manner. So it is called as projecting pole type. The north and south poles always in a projecting poles from the rotor construction. The rotor has two slip rings. It will be directly connected to DC source. It has in a salient pole type rotors is very suitable for slow and moderate speed applications. So it will be very less expensive type rotors. It is not suitable for high speed generator and difficult of obtain the sufficient mechanical strength. It is also made of thick steel lamination. Then the four faces are usually provided with a slot for damper winding. The dampers are always used to prevent the hunting. Then we will see about features of salient pole type rotor. It has a large dia and short axial length, and also the pole shoes covers about 2 to 3 of the, that is 2/3 of the pole pitch. Then the lamination is used to reduce the eddy current losses, and also it is applicable for hydraulic turbine and a diesel engine because the speed varies from 120 to 400 rpm, because salient pole is always applicable to used to reduce the small and moderate speed alternators. A non-salient pole application, we will see the construction cross-sectional view of the smooth symmetrical type alternator. Here the poles are the non-salient, north and south poles are non-salient. Here also the rotor as the two slip rings, it will be directly connected to DC supply. The field windings are connected in between the north and south poles. It is used for very high speed application, and also it is reduces the peripheral velocity and diameter of the rotor. So once the diameter of the rotor is reduced and axial length is increased, and also it have 2 or 4 poles, it consists symmetrical steel forging which is suitable fabricated mechanically and treated thermally. The features of non-salient pole types are small dia and a very long axial length, and the less windage loss, and this speed employed with 1000 to 3000 rpm, because it will be suitable for above the synchronous speed. So the synchronous speed is 1500 rpm, so it will be used to 3 up to 3000 rpm, and also it is better in dynamic balancing, and it has quieter operation. So first we will see about major difference between salient and non-salient pole. So salient and non-salient pole. The salient pole has large dia and a short axial length, but non-salient pole has small dia and a long axial length. The salient poles are used for low speed alternators, but non-salient poles are suitable for high speed turbo alternators. In salient pole type rotors are projecting type poles, but non-salient poles are not projecting poles. In salient pole, dampened windings are required because of to prevent the hunting, but non-salient poles are does not require damper windings. In salient pole type, windage loss is much more greater than the non-salient pole, but in a non-salient pole type rotor, windage loss is less. This is the major difference of salient and non-salient pole type rotors. Then we will see about working principle and working of alternator. This is the overview of alternators. So the three-phase supply will be connected to stator, and the rotor will be placed in center of the stator part. Then the rotor will be rotates, armature conductors are cut the magnetic fields, hence the EMF is induced in the armature conductor. This is the basic fundamental principle of generator, that is DC generator. The direction of induced EMF will be founded by Fleming's right hand rule. Then the frequency of the alternator is directly proportional to the synchronous speed, that is F is equal to Pn divided by 120, or else the synchronous speed N is equal to 120 F by P. The 120 will be cross made and P will be divided. So N is equal to 120 F by P, or else F is equal to Pn divided by 120, where N is the speed of the rotor and P is the number of poles in a alternator. This is the simple construction detail and working principle of the alternator. If you like this video, like, share and comment this video. Thank you friends.